yes, it's just a wonderful video in short. I'm going to talk about Python free course that my Divine Academy is offering. And who is taking that course? Me and two industry experts. We are together taking this wonderful course for free for you. All for you actually. And we are following a wonderful syllabus. Why? Because most of the courses in Python will tell you, let's start with Python, let's learn this, like that. We will not only teach you Python. We are going to teach you 3 web dev frameworks of Python, 5 GUI frameworks of Python. We'll teach you object-oriented programming concepts, data structures and algorithms concepts, pseudocodes, programming logic, dynamic programming, and all this through Python. And in the end of this course, we are going to create an API with Python. We are going to build neural networks with Python, and all of this for free. So what's the catch? Nothing of a catch basically. All you have to do is get enrolled. Batch size is limited. We are only taking 50 students. So be the first 50 to enroll. The next batch will be launching maybe after December. So, and I don't know if that will be free or not. So I guess you better take the opportunity as fast as possible. Now, a screenshot of this will be available in the description box. Or you can take it right now if it's visible. I don't really know because the light problem is a little bit too much. I don't think the glare will make you take a good screenshot. But still, yeah. If you have taken the screenshot, you can read from here that Python is definitely not the language you can use for programming in competitive platforms. Some job interview portals and the technical portals over there, they don't even have the Python compiler working the proper way. Some are even having the option of like Python 2. So I guess there you have a problem, but don't worry, we're going to build you into a machine who can process any programming language in a very limited time span. So yeah, this is definitely going to be a course to look at, and I'm going to give you a brief intro to the wonders of this course. I'm going to teach you today how to use programming knowledge and how to use the concept of data structures to reduce the time compressibility of your program, and at the same time I will teach you some rather cool stuff with some very common stuff, and you're gonna love this small video. So without wasting any more of your time and without showing my ugly face anymore, let's get started. So I told you I will show you some tips and tricks with Python programming, things that we will definitely talk about in that free course as well. But let's just give you a brief of an intro, right? So let's just talk about this thing. I guess all of you know about this factorial, right? Factorial of a number, like if I tell you, say, find me the factorial of 5, you know it's 5 into 4 into 3 into 2 into 1. Basically, the factorial of n is just the product of n into n minus 1 into n minus 2. This it just goes on till it's like n minus 1, and like that. It just keeps going. But the problem is, when it comes to recursion, and if I make a recursion tree of this, so what is it basically? This is fact n into n minus 1. So if I make the tree of this, so if I'm trying to find the factorial of 5, okay, so I'm getting what is there? I'm get 5, and then the function is returning itself with factor 4, right? Then I have 4, and the function returns fact of 3, and then we have 3 and then fact of 2, right? Like this it goes. So let me just scroll up a bit. Yeah, so then this becomes 2, this becomes fact of 1, and then fact of 0, where it basically returns to the base condition, which is 1. It prints up. So it works like that, and it has the space complexity is basically the height of the tree, which is n height. So height is basically n. So the space becomes O of n, but in terms of the time complexity, you can see it also occupies that height of the tree, which is 1, 2, 3, 4, 5. That is n basically. So it's n is 1 takes it to n. It's kind of cool, but space is taking up a lot of things. And then if we do it with this f equals to f into I thing, for this loop running from 1 to n, so basically this is running n times, and this f thing is running up to I, is connected to I. This I is also running to n times. So basically it's n into n, and it becomes O of n square. Space this is time, and space remains as O of n. It's fine, but the time complexity actually goes to n square. So it's not really an efficient way to solve this thing, in my opinion. So what we can do is, it's not just for Python, for any programming language actually, you can try and opt to solve it in some different manner, so with some different approach. So my approach would be to use an array. My approach would be to use an array. How would I use an array? So for array, I know it's a memory block, right? An array is mutable. I can change this. In Python, maybe I'll use a list here, not an array, rather a list. Okay, works fine just for arrays as well. So you can just mutate a list, right? Or an array. So if I just make an array which initially has zeros, okay. So what I can do is, now I have all the zeros, I'm going to mutate these. So this first position of 0, I'll occupy it with 1. And for the next position, I want the product of, this is the loop, right? So it will be 0, 1, 2, 3, 4. This is the index position. So what I want is, I want the product of this index and this element. Then that will be giving me 1. Then again, index and element product gives me 2. Index and element will give me 6. Index and element will give me 24. But wait, I'm going for 5 times, right? Since index starts with 0, and the fifth factorial should be here, because now I'll have an index of 5. So now 5 into 24 will give me 120. So this means the length of this array, should be n plus 1. Yes, then I'll get it at nth position. The nth position stores it. So the formula is basically, for array at an index, position, I am basically replacing that 0 value with array of index minus 1. Index minus 1, and I am multiplying it with index, right? Now why I am doing this? Because this is already declared. So I'm already declaring it, that the first block will be 1. I'm initializing it myself, and then I'm moving forward with it. Kind of makes sense to me. It's good to think like this, because I'm reducing the space complexity to of constant 1. This is for space, and the time complexity gets reduced to of n, which is pretty cool. Pretty cool. We are not using recursion, we're not using anything, we're just using a fundamental data structure, right? And it's an easy way to think of it. It's not a complicated logic. So let's try to implement it. I'm going to use REPL. Why I'm using REPL? Not because it's an official sponsor of us or something. Okay, it is, but still, it's a pretty cool thing actually. You can even go to the inspect view, and you can like open it with mobile, you know, mobile side, desktop side. It just fits in. It's very responsive. So you can like practice coding in your mobile phone, though I highly do not recommend it. Oh, wait, I don't just, let me just come over here, and let me just go to, what was the building? Logic building. Okay. what logic did I build over here? Okay, ignoring all of that, let me see what logic was I building. Okay, let's just open this. By default the name will be main.py. Okay, so I need to change it actually. So let me just pull up with the logic. So let me just def fact, we'll put number n. Now we need an array, so it will basically be a list with 0 initially, and it should be stored like n plus 1 times. Okay, now let's see. I'm going to create, or rather this, I just name it something more sensible. Let me name it fact. Okay, this makes more sense. Yeah. Okay, now for this array, at 0th position I'm going to fill it with 1, right? This is the 0th position. Oops. Okay, so at 0th position we have this one. Now let's do one thing. I'll just come over here and I'll initialize the for loop. Just range it out from 1. Now for those who might just wonder why I'm starting off with 1, because I've already initialized the 0th position, right? 0th position is already initialized, so I'm going to start with first position, right? Let's go ahead, and this is going to run till n plus 1 because the length of the array was n plus 1. Cool. Now what I'm going to do is I'm just going to look into this formula thing. So what formula did I have? This is the formula, array at index. So what was this index? This is the loop, right, which is storing the index thing. So the loop variable is I. So let me write fact at I is equal to fact at I minus 1, and I'm multiplying I with it. So it's like index. Alright. Now if I just return fact at no n plus 1, should be my answer. This should be the answer. So we just print fact of 5. So it should give me 120. Let's see. Okay, what was the problem? Alright. Yeah. Okay, so I just rectify myself over here. It should not be n plus 1 because that was the limit till where we ran, right? So it should be n. That's 1 less than the length. Because the last length it traversed was supposed to be n plus 1. I just write it down. Okay, so if I write range, if I go through a range function, if it's m comma n, so basically it runs from m to n minus 1, right? So I ran from 1 to n plus 1. Like, I'm really sorry, let me just write it like this. The range function that I used was like this, n plus 1. So it basically ran from 1 to n plus 1 minus 1, right? So it ran till n. This was the last index, and here I had my answer, right? So I had to run it till n. Okay, so this we covered up in a very short time compressibility thing. Cool. Pretty cool stuff. Yeah. You get the source code in the description box, though I guess it's absolutely not needed. This is very like basic thing. Let's spice the things up a bit more. And by the way, this is kind of like an intro to dynamic programming. You might just wonder, right? But it's actually kind of like an intro to dynamic programming, so it's kind of cool. Okay, now if you move on, there's a small thing that I remember. People made a lot of fuss about it, but I don't think why people made so much in Python. Minions game problem. It was in a hacker rank, right? Yeah, I guess this problem was in Hackerrank. Yeah, this one. So one of my friends just gave this to me long back, not very recently. So this is kind of a cool problem actually. You can just go ahead and read this problem. This is the minion games problem. If you read the game rules, you can see both players are given the same string. Both players have to make substrings in the letter S. Stuart has to make words with consonants. Kevin has to make words with vowels. The game ends when both players have made all possible substrings. Now, whenever these kinds of problems come, okay, people get panicked by the amount of writing up here. What you have to do first is ignore this, ignore this, start from here. Always start from this example part. Now, this might vary from person to person how they start it. I found this the easiest way, and I'm not your expert coder, I'm an average coder, right? And an expert is not going to see my course. An expert already knows everything. An average or a rather a bad coder would see this, right? So I will tell you from my point of view how I would have started. So I would have started from this example part. Okay. So saying that say S is banana, Kevin's vowel beginning word is ANA. Okay, it starts from vowel. So for Kevin, he scores when he starts from a vowel. Now next thing comes this triangular thing. So we have B, we have N. Okay, so we can see this is a consonant. Starts with the consonant, this starts with the consonant, then again starts with the consonant. So all the points from where it can start with a consonant, it should start from there. Okay, and it's coding up. So let me see the scores. Na. Okay, so this substring is occurring two times. This is the occurrence of the substring. So this is score is basically frequency of the substring. Okay, that's cool. And over here we can see the very same thing. An is occurring two times, a occurs three times. So this looks a bit complicated at the moment, right? How are we going to store this? We're going to use hash map. I'm going to use dictionary. This, that. No, 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 no. This is not that kind of a question. Can you see this? This difficulty medium. It's such a rubbish thing. Forcing you to use some complicated data structure. It's not like that. When you see, let me just tell this to you, might sound a bit brash, but whenever you have this kinds of triangles, right, you can see a continuous thing happening over here. A continuous, something continuous is happening. So we obviously need a loop. We obviously need a loop. And I would recommend that we store it in a string or an array. String or array if you're using C. Okay. And then accordingly connect this loop with a score variable. Why this loop? Because as the loop traverses through it, I would like the score to update accordingly. So what I'm meaning by that is, let me first write the code here. In this specific case, let me try to find out a logic first, then I'm going to write the code. Okay, this is how it actually works, right? We first make out the logic. So what I'm thinking is that I will keep a tub of vowels which will have this A, E, I, O, and U, right? So we have a vowels container where I'll have this. So we'll have Stuart's score and we'll have Kevin's score, and both of them will be 0. Both of them should be set to 0, right? Both of them should be set to 0. Okay, 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 great. Now we have to find the length of the string, right? So let me see. So I'm going to run a for loop. So let me say I run a for loop x from say 0 to length of the input string, the one that I'm going to input, right? So now inside this loop what I'm going to do It's just inside of this loop, inside of this loop, inside x. What I'm going to do? So inside of x, I'm going to update my score variable, and I'm going to update score as length of the string minus of x. Okay, so why am I doing this? Now if you come over here, can you see from the very bottom that the length is continuously decreasing, and it's constant, right, for everywhere? It's decreasing continuously. So if you have got my approach, what I'm using over here, then you would understand that I'm going to start like this. I'm going from down to up. That's my approach. And whenever you have a triangle thing, right, you try to do it this way only. Take the largest chunk. So I'm happening to use the brute force approach. I'm happening to use a brute force approach over here. But the brute force approach is also giving me an O of n, and the optimized approach is kind of giving me O of n log n. Okay, so if I draw O of n, it's like this for O of n. For O of n log n, it's kind of like this. So if I just cross breed this, only for this section of area, which happens to be almost less. So this thing is kind of acceptable. It's really good of a time complexity. Not very bad. It's like, so we don't have to focus on this and unnecessarily waste time. So we can just very well start with the brute force method over here. All right, so here we begin. Now the rest of the thing is like a piece of cake. So if this very index, okay, if str at this index x is equal to a vowel, okay, then obviously it goes to Kevin's score, else it goes to Stuart's score. Yes, Stuart's score, right? So what will be Stuart's score? Or nothing, we just plus this thing, we just add up to this thing, right? Just add them their scores. Yeah, it automatically finds their things, and then we'll check if it's draw. If Stuart's score is equals to Kevin's score, it's a draw. If Stuart's score is greater than Kevin's score, it's Stuart is the winner, else obviously Kevin is the winner. Awesome. Let's build this up. Let's build this up. In fact, we can just directly write it here only, right? Okay. So I've already written down the code over here. Let me tell this to you. Okay. Oh, and by the way, this if name equal main thing over here, this thing is something of a very good practice. So I often tell people to follow this practice. Okay. It's very cool. So let me just show this code to you. I'll just maybe copy this thing in the REPL platform and show it to you. Yeah. Alright, so I have written this code. So I have vowels A, E, I, O, U. Okay, so in Python you have that flexibility of using this in line. This is in command, and you can see in the range. So I've named this X as start index so that it makes more sense. So we're reducing start index from length. We are checking if it's in vowels, then we're updating Kevin's score, else we're updating Stuart's score, and we're checking that draw thing here. Right. Okay, seems fair to me. Let me just run this code. Okay, I just connect. Not signed in. Wow. And that's my personal Hackerrank profile. You can always follow me up there. In fact, I'll just give my GitHub link as well. And works with this one. Let me submit this code. Should work for the test cases. Yep. Perfecto. Alright, so we just solved a medium problem, which is like easy, right? I feel like it was easy. Anyways, it was easy actually, trust me. It was really easy. Okay. Now, let me tell you another very interesting thing. Let's see how I see this another thing called patterns. Now, you see, even pattern problems tend to follow monotonous approach, and people often juggle it up. They're like, I have this method, I have that method. They don't, no one talks about the best method. Okay, and sometimes they do talk about the best method. So what I want to tell you about patterns is a very honest opinion about patterns is, first thing, it won't come in the interviews. Okay, it won't come in the interviews. Trust me. Neither they will ask you to do them in colleges. So why we do it? It just sharpens your aptitude problems, sharpens you, right? Instead of drinking Horlicks, you can like practice patterns that would sharpen your mind more. Okay. Even now, when I feel like I want to like keep my mind in good exercise, I do some pattern problems. You can always increase your level up. So pattern won't come in your interviews, but pattern problems cannot be solved with one single approach. Cannot be solved with one approach. Tick. So you cannot solve it with one approach. There should be multiple methods that you know actually. So there was with this one method where we just have the k thing updated. Like for example, let me just tell you, if I have this as star, which is this with the star, you can follow an approach of using a k variable that just keeps incrementing. So if I use this k equal to 1, and then we are going to print like we have a question, if k is greater than equal to, this is the midpoint, let me say it's mid, and we find a way to calculate this mid. Okay, so if k is greater than equal to mid, then we'll have like k minus minus, reducing k, and else we are like incrementing k. So in that way we'll have something like this: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, something like this, which will not be the thing that I would want if I had replaced this thing with 1 1 2 1 2 3 1 2 3 4 1 2 3 4 5. Okay, so it will next it be 1 2 3 4 1 2 3 1 2 and 1. Okay, this will be the nth term. So this is how it's going to work, right? I want this pattern to come. Now if I see this as the stopping point, so I'm doing it for 5, right? So this is 5. It's running for how many times? 1 2 3 4 5 6 7 8 9. It's running like 9 times. It's kind of cool. So what I'm going to do over here is that I'm going to like create this thing, and we'll find logic for this. Wait, so it's running from, if it's n. Now acha, by the way, I guess this is already known to you, but these things are rows, right? These things are rows. So let's establish the number of rows that we need. So the number of rows for n as input, rows will be equal to n into 2, right? Good. Okay, but what is the column value? So column is basically equal to row, right? This is the fifth column, and we are having this like this is the fifth column, this is the fifth row. So it's this equal to column up till we are here at n. Up till n. So till we are at n, column is equal to row. But after that, how is it decreasing? Let me see. 1 2 3 4, so we're reducing 1 from this, so it's basically, this is 6, right? This I thing is over here 6, if we consider this as I or whatever it is. And this can be, if I say 2 multiplied by 5, that is this point, 10 minus the very row 6, then I get 4. Yeah, this matches. This matches. Let me just check over here. Yeah, this I is over here like 5. So it's 2 into 5 minus 6 is 4. So it should be, let me just confirm it for this one. So 2 into 5 minus 7, 10 minus 7, it's 3. Okay, so we got it. Now the question comes that how did you get this very logic? How did it all of a sudden click in your mind? Well, that's because I know one thing for sure. This is not a shortcut trick or any cheat trick, okay? So this logic for the column, this column logic, in all cases, must include, must have variables of length or limit, rather, the parent loop, which was I over here, I here, and a constant. So I already knew I will have n, and I already knew I will have I, and then I started to fill the pieces. So I first felt that since the last point was 10, so maybe it would be 2n. Okay, and then I felt that okay, I have to remove I from this, like I have to connect it with I. If I do add it from here, it's definitely not adding up, right? Here we reduce to 1 space, we're reducing 2 space, reducing 3 spaces, then we're reducing 4 spaces. And once this happened now, this is 4, right? And this is at 10. So then I realized this thing. Okay, this is how I realized that this is subtracting it. So I just added a subtraction sign. This is how this logic works. Okay, so let me name it def pattern, and there will be n lines of input. So we have a for I in range. So I'm going to range it from 1 till 2 into n. Okay, so we have a column, and column should run for 2 into n minus of I, right? But yeah, there's a small catch over here. So I'm going to write, I will say column will be I if column will be equal to I, like column is equal to row, if I is less than equal to n. Still this is a pivot point over here. Else what we're going to do, else I'm going to put that very formula, which was 2 into n minus I. So we have it, 2 into n minus I. Now we're going to run a for loop. So this for loop will be, let me say j, okay, and this range will go from 1 till col plus 1, should run till column. Okay, I didn't write 1 over here. Yeah, now it's fine. So what I'm going to do is I'm going to print j, and should be like this, and I should print something like this. By default will take slash n, so I don't need to take in slash n. Just this pattern, and pattern I'm going to input 5. Let's see if it works. Bingo, it's working exactly how we wanted it. So wasn't that cool, right? We just grabbed this logic like so fast. This is having an O of n square. Now don't worry about the time compressibility for patterns, it really doesn't matter. Okay, so here it happened. Alright, now let me just tell you a very fun fact about all this stuff. Okay, so every time we're using this Python, there's a small problem with Python is that in Python you really have very slow loops, especially the while loops. So in most of the times, if you are to use a loop, avoid a while loop. So even for a basic program like a digit extraction program, we tend to use the for loop, right? We tend to use the for loop. Now, for me, I would say that I wouldn't prefer a for loop anywhere, but here I can use the for loop. Now, let me say that n is an input. Now, basically, we take an integer input, but here we take a string input. Now, for digit in n, we can just make sums equal to sums plus int of digit. It's basically just an O of n, right? This is O of n. So what do we say? Say 5. Sum of, okay, we are supposed to find sum of digits 1, 5, 6. Let me see, 15. Alright, so it's working very well. Now, in case, let me just give a bigger input. Let me see. Yeah, working fine. Now, if I just really replace this with the standard while code, so just uncomment this n. Here we can take int as input, right? We're using the standard while loop now. So if I say while n is greater than 0, digit equals to n modulus of 10, sums is equal to sums plus digit, and then we have n equals to n double slash 10, and we just need to initialize sums here. Now we just need to print sums. Yeah, just print it. So you can see the glitch over here, right? See the difference in printing time. Exactly, it's almost the same length, right? So this is the second approach of while loop that we use, right? So why I tend not to use this thing is because in this case over here, we're kind of reusing this thing over here, right? We are using this digit thing again, yeah. So we are linking it with the for loop. So that again gives a space compressibility problem. And here we are also having a O of n, and here also we are having an O of n space complexity. So this absolutely no sense. And this thing, when you do it like this, instead of any typecasting, not putting much pressure in the memory, this kind of works like a charm, this very process. Now for those who kind of like don't know how this basic digit extraction thing works, they can surely listen to the next 5 minutes. Else this was the only thing left to tell, so you can just end this video right now. So I just tell you about this digit extraction formula. Tell you about this digit extraction formula. So how this works is, so when I'm saying this, let me just write this small part of this code where I'm saying that n greater than 0. Oh, by the way, let me just show you a small thing with this. Let me just click on the print screen, and now I paste this over here. Okay, now I can zoom in like this. I can crop out the exact part I want. See how cool this Miro thing is. And just drag and reposition it, and here we go. Cool, right? Now start like this. Let it pick a more cheesy color. Okay. So sums is storing 0, while n is greater than 0. So let me just write a column where there I have n's value, we have sums value, and we have digit value. So first of n is equal to, let's say I want to add 1, 2 and 3. Sum of digits will be 1 plus 2 plus 3, that will be 6. So first n is 123. Now digit is what? N modulus of 3, 10, sorry. Yeah. So if you divide like 123, if you divide it with 10, it will be like 10, and then we have 23, right? 2. So what are we left with? 3. Basically the last digit. We are rest with the last digit. So let me just write it down over here. And the sums will be what? First it was 0, right? So it will be 0 plus 3, sums plus digit. That will give me 3 itself. Now when I am doing n slash slash 10, it takes the quotient. This very thing is up for the quotient. This is for quotient. So if I am targeting the quotient, it will be 12. So it gets reduced to 12. Now when you are performing modulus on 12, modulus by 10, what are we getting? We're getting the last digit again, we get 2. So now the sums plus digit. So what was the former value of sums? 3, right? So it will be 3, and now the new value of digits is 2. So we're getting 3 plus 2, 5. And then again when we are performing this line, I get 1 last digit, right? So we are performing this on 12, so we are having n equals to like, once you have like 12 you get 1, and then we have 2. So now we are left with 1, last digit is 1, and the quotient, the new n, becomes what? After this it will become 0, and here it will be like 5 plus 1 is equal to 6. The answer is there. Now when it becomes 0 over here, it should stop because it's not greater than 0 anymore, it's 0. So it just stops over here. It just stops. Why it becomes 0 actually? So once you have 1, right? So you're dividing it with what? You're doing it with the number itself. So what was the number? It was like 12. Yeah, so the quotient will be 0, right? The quotient becomes 0. This is the quotient. So that's why it stops over here. Okay, so this is how this small thing works. And next comes the very thing called prime number. Now people tend to make a lot of problems with prime number. The ideal time compressibility for a prime number should be O root n, and it's not very difficult to achieve, trust me. So what you'll have to do, then you're going to start your for loop, or let me rather say I have a prime number. What can be a prime number? Let it be 7. Okay, and let's say a non-prime number, let me say 25. So what are the factors of 25? 1, 5, 25. Okay, let's take any other random number, say 36. Okay, let me take 34. So what are the factors of 34 coming to? Just rarely, like I do this, let me open calculator. I've opened it 3 times. So I find the square root of 34. It's like 5.8 or something. Let me say it ignores the fractional part and I get 5. So the factors of 34 can line from 1, then it will be 2, then dot dot dot, just goes there. So what I'm saying is, within the square root, this is the square root, within the square root, the factor lies if there has been any. If there is a factor, it will lie within the square root. So what I can do is, for finding a prime number, so prime number in O of root n, what I can do is I can write a def prime, we just write n. Okay, so we have a count equal to 0, full thing, for I in range. Let's check this up. So I'm going to run from 1. So why would I run from 1? Let me just run from 2. Okay, and we're just gonna run from this to int of square root of n. Yeah, so let me see, I'm running it to square root of n, and if n mod of I equals 0, then count equals to 1, and I can just literally break because I found a factor, so it doesn't really mean that I need to check for anything else now. I really do not need to check for anything now. So the count is equal to 1 now. Breaking out, if count is not equal to 1, then I can print not prime, as I can literally print prime. Right? So we can just import the math function, or we can just define a square root function. I'll just define a square root function. So if we have an n in square root, we can like return n to the power 0.5. That's basically square root. Just run this. I'll put in 7. Okay, I just not called the function only, sorry. So let me see, I just want to see prime of 7. Okay, should see it. Calling me not prime. Oh, sorry. It just happens. Maybe I'm high on coffee. Let me just put for 17. Should show me prime. Move for 15. Okay, works well. That's it. do one thing and just have to increase it by plus one. Not prime, yeah. Sugar. I just forgot the range thing goes for -1. So we make small mistakes like this also. I could have just edited this out, but I thought it should be kind of raw. Okay, so this was all the fun stuff for today. I'll be back with more videos like that. Till then, if you really enjoyed the content, go ahead and subscribe the channel. See in the description box, get enrolled in the course, and we'll have nights of fun every day because I'm more active in that community thing, that project things. Just go ahead and check it out.